Hi everyone, thank you for joining me today. And today I would like to talk about how to troubleshoot and monitor your production application using OpenTelemetry. So the agenda for today will be to talk about observability, understand the definition of observability. Then we will talk about OpenTelemetry and what OpenTelemetry provides, and how we can leverage this open source project in order to gain observability and better monitoring for our application. After this, I would like to go over a specific use case of a memory leak, where we will see how we can analyze the problem and diagnose the problem. And hopefully we'll finish with a live demo. No code. I will just show you another open source called Teletrace, we will talk about a bit later. So a little bit about me. My name is Reut Baruch. I work for Cisco Outshift Group, previously known as ETNI. I'm a software engineer and I'm a Teletrace open source maintainer, where Teletrace is an open source project that helps you monitor, visualize, and debug your system with distributed traces, and it is based on OpenTelemetry. So let's start. What is observability? The definition of observability is knowing the internal state of our system by looking at the external signal. So basically, knowing what's going on inside our system by looking at what signals the system produces. So in simpler terms, having observability will be having the ability to answer questions such as what happens inside our system and why our system behaving the way it is. I'm sorry, it's really loud. Okay. So let's look at this architecture. This is a monolith architecture when all the logic runs on a single host. And let's say we deployed it, and now we want to understand what's going on inside our system. So what we usually do is we install an agent that will collect some metrics, send it to a dashboard such as a Grafana, where we can analyze and visualize what's going on inside our system. And we can see if we have issues or not. And let's say that we do have an issue. What we will usually do next is we install another agent that will collect the logs, send it to some log aggregator where we can view, analyze, and look over the logs in order to understand why the problem happened. But what happens when we talk about microservices architecture? So many companies are moving from monolith architecture to microservices, and for a lot of different reasons, a lot of advantages and disadvantages. But when moving to a microservices architecture, it really presents some difficulties, some challenges for the development team. Because when we are talking about a microservices architecture, if we want, we can see that there are a lot of different services, different frameworks. It's very difficult to understand which service is connected to which service talks to which service, and what service participant in which flow. So gaining observability, understanding what's going on inside our system with this kind of architecture, it's a bit more difficult than in the monolith architecture. And the differences between those architectures brings us to talk about three main challenges that a development team will face when trying to gain observability. First challenge will be modeling. So if we go back to the definition of observability, it's understanding in which state the system is currently in. But when we talk about a microservices architecture, there are so many states that the system can be in. So even understanding what are the different states that our system can be in, it's really difficult. And that will be the first challenge, to model and understand which service is connected to which service and which service participant in which flow. Second challenge will be troubleshooting the system. So let's say that we have an alert, but we have too many 500 error, okay? We have the internal service error. Now if we want to understand the root cause, we want to understand the problem, we need to, we need to go over different logs of different services. We need to correlate between them, and until we find the root cause, until we find where the problem happened, which microservice is responsible for this issue, and only then we can try and fix it. So troubleshooting the system will be a bit of a challenge. Third challenge that we will talk about is optimizing the system, because let's say that we have a customer complaining that a specific flow in the system is not as fast as expected, right? So it's pretty much of the same. We need to go over a lot of logs of a lot of different services, and we need to try to correlate them until we find which service is responsible for this latency. And only then we will be able to find the root cause and try to fix the problem. So in order to deal with these challenges, we have the 3 pillars of observability: metrics, logs, and traces. And metrics are basically numbers over time, and the purpose of metrics is to tell us what happens in the entire system. So you probably know metrics as like CPU usage, memory usage, where you can find your CPU over time, right? Second one will be logs, and it's the most essential kind of output, because like almost every system, every product produces logs, and logs tell us why something happened in our system. And lastly, we have the traces, and the purpose of traces is to talk about where something happened in our system. But when we talk about distributed systems, we need to talk about distributed traces. And this is a representation of a distributed trace over time. And the purpose, a distributed trace basically tells us the story of an entire transaction as it propagates through the system. So in this representation, we can see the trace over time, where each tile is a span, and all the spans together create a trace. So a span is a single unit of work, and it's usually a representation of one microservice, one specific request in the system. And as I said, all of this together creates the trace. And as we can see in this representation, it can be really easy to understand if we have latency issues, right? Because we can see the different amount of time that each span takes. But I want you to see a different representation of a trace, which is a graph view. And in this representation, each microservice is a node. Okay, every node is a microservice in the system, and the errors between them are one or more spans in the system. And in this representation, we can easily see that we have a problem in the request. Okay, and then we can navigate directly to this specific microservice, dig into the logs, and understand the root cause. So we immediately found the where the error happened. And it's really nice and pretty. It's really easy to visualize it. But how do we implement it? Because we need to collect a lot of spans from a lot of different services. We need to propagate the context between them so we can connect between them in our backend afterwards. We need to store it, we need to export it, we need to create some nice UI so we will be able to visualize it and try to analyze when we do have issues. So this is where OpenTelemetry comes for the rescue, and this is why we use OpenTelemetry. So OpenTelemetry is an open source project. It is part of the CNCF, which is a Cloud Native Computing Foundation. And this open source is not backed by a single company, but by a wide range of vendors and contributors that are maintaining this project. So it has a really large community. And the definition of OpenTelemetry is that it's a collection of tools, APIs, and SDK that helps us instrument, generate, collect, and export telemetry data, when telemetry data being metrics, logs, and traces. And if we look at this architecture, this is a typical OpenTelemetry architecture. we can see that we have the APIs and SDK running beside our application, but it can also be part of our application. Same goes for the processors and exporters. They can run beside our application or inside it. After this, we have the collector, which we will talk a bit more in a few minutes. And the last thing we have is the telemetry backend. And an important note, the telemetry backend is not part of OpenTelemetry. It's outside the project scope, but I will talk about the different backends that you can use when you have OpenTelemetry as your data source. So let's talk about what OpenTelemetry provides. And the first thing that we will talk about is the specification. And the specifications are the definitions of how the telemetry data should look like. So how does a span look like? What's the metrics? What is a trace? And so on. And it also specifies what are the expectations of the SDK and the API, how it should look like and how we should implement it for every programming language. Second thing is the language SDK. So for every programming language, we have the language SDK, which is basically the implementation of the definitions. Of the specifications, the definitions of the API and so on. And this goes for every specific language. And what we will usually have is two repositories. One will be the core repository, where we will have the implementations of the SDK. And second one will be the contrib repository, where we will have extensions for the language. And in the contrib repository, we will have the processors, the different processors that help us process the data before exporting it, and also the different exporters that will help us export the data to different backends, or the OpenTelemetry collector. And another cool thing that OpenTelemetry provides is the automatic instrumentation. So if we look again at the example of the distributed trace, we can see that we are using a lot of different frameworks, a lot of different services, and from every service, from every framework, we need to collect the data. So we need to collect, for example, transaction ID, customer ID. If it's an HTTP, we want the operation, the return code, and so on. And we don't want to do all of this work manually for each service. We want to do it automatically. So this is what's cool about OpenTelemetry, that it provides automatic instrumentation with minimal code changes when adding it to your application. And finally, we get to talk about the collector. So the collector can receive data from many different OpenTelemetry agents or applications that use OpenTelemetry. And it can also receive data from data sources that are external to OpenTelemetry. And inside a collector, we can have the receivers, processors, and exporters. Okay, so we can define it inside of our collector. But as I said previously, we can also have the exporters as part of our application. So why should we use the collector, right? So we should use the collector for a lot of different reasons, but one of them can be like if we want to reduce overhead from our application. So if we want our application to not have the overhead of connecting to the backend and sending the data over the network, or also if we want to have like a one central location for the collector when it is responsible for all of the logic of processing the data and sending it to a backend. And also if we want to have like some logic in our processors, right? If we want to remove some sensitive data, for example, before sending it to our backend or to a storage location. So in general, I would recommend using the collector alongside your service, since it allows the service to offload data quickly. And the collector can take care of additional handling like retries, batching, encryption, and even sensitive data filtering. Okay, so the current status of the major functionalities of OpenTelemetry is stable. And we have different repositories in the GitHub Java repository. And I would like to talk about a specific one, which is the OpenTelemetry Java instrumentation, which is built on top of OpenTelemetry Java. And it provides us the Java agent. And the Java agent can be attached to any Java 8 plus applications, and it dynamically injects bytecodes to capture telemetry data from a number of popular libraries and frameworks, so we can save a lot of work just using the agent. And another few words about the OpenTelemetry Java agent is, first of all, the automatic instrumentation. So as I said, it really hooks into your application and into application at runtime, and it dynamically instruments your components, and it sends the data. And the component being such as HTTP frameworks, databases, messaging system, and so on. And a cool thing about it is it has really configuration flexibility, so you can define the agent provides configuration options, so you can optimize its behavior, meaning it allows you to control which libraries you want to instrument, which not. It's really like fine-tuning of the captured data. And lastly, it's like zero code changes, so you can just implement it, you can just use it in the application, and there is no need to add another code into your application. So, as I promised, I would like to talk about the different OpenTelemetry backends. And we have a couple of open source backends that you can use, where we have Zipkin and Jaeger for traces, Prometheus for metrics, and Grafana is an open observability platform, so we have Grafana Loki, Grafana Tempo, and so on. But I would also like to talk about Teletrace. And Teletrace is an open source that was developed inside Cisco, and it helps you monitor and analyze your data using OpenTelemetry traces, and it supports OpenTelemetry natively. And in the demo, I will show you a little bit of how to use Teletrace in order to monitor your application. There are a lot of commercial solutions when using OpenTelemetry. So what you can do is just go into OpenTelemetry vendor's website, look at all the commercial solutions that support OpenTelemetry, and use it, choose which one is better for you for your specific use case. And another solution that Cisco provides is AppDynamic Cloud. It's not an open source, but it's also it's AppDynamic Cloud. It also helps you monitor and troubleshoot cloud-native applications, and it also supports OpenTelemetry natively. So these are the different backends that you can use. And another thing I want to talk about regarding OpenTelemetry is the amazing thing that OpenTelemetry gives us is the community. So the community gives us a lot of support and a lot of different tools, but one thing that it provides is the amazing documentation of OpenTelemetry, where you can find all that you need in order to how to use OpenTelemetry, how to contribute, how to use your own instrumentation, and so on. Obviously, we have the GitHub repositories where you can find all the issues and all the different things that happens inside GitHub. It's also public and opens to everyone. We also have Slack channels. So if you go to the CNCF Slack channel, you can just find all the Slack channels regarding OpenTelemetry, where you can ask questions, you can get some help from maintainers or some other community contributors. And we also have SIG meeting. So for every subgroup, we have a SIG, which is a special interest group, and it manages its specific sub-project. So those groups usually meet once a week. So if you have something that you want to discuss or something that you want to ask, you can just join this meeting and add it to the agenda. And lastly, another amazing thing that OpenTelemetry provides is the OpenTelemetry demo. So it's basically an application, a web store for telescope equipment. And you can just go and use this demo in order to feel for yourself how it's like to use OpenTelemetry. So as I said, this is a web store in a microservices architecture. This is the architecture for the demo, the community demo. So there are a lot of different frameworks, different services, and you can really play with it for yourself and gain the feeling of what it's like to use OpenTelemetry. Okay, so having said that and going over the basics and the definitions, I would like to talk about a specific scenario of a memory leak use case. And in this scenario, we'll go over a demonstration of how to move from a high-level metrics and traces and determine the cause of a memory leak. So the first step of diagnosing a problem is determining that you have a problem, that a problem exists. So usually the first step will be going to some dashboards such as Grafana. And here we can take a look at the different charts. So we can see that in the error rate chart, which is the second one on the right, you can see that we have no errors, right? But if we look at the recommendation service CPU, we have some spikes over there. And also like at the bottom, in the service latency, we have like a long latency tail and also some spikes in the memory chart. So it can really makes us suspect that we do have a memory leak. But what do we do next? So what I would do is go over to Teletrace. And this is the search page of Teletrace. And I'll filter by the recommendation service because I know that this is the problematic service. In here we can see all the different spans that are related to this specific service. And if we take a close look, we can see that the duration increases. You see, right? I can obviously filter by the duration, and we can see that it increases. So by clicking on a specific span, it will immediately open us the trace view page. So we have three different visualization in this page. First one is the timeline in the bottom, where we can see the duration of the different spans. We also have the graph view and the span details. So the spans that are opened here are related to the selected node in the graph. So if we select a different node, different spans will appear. And when we take a closer look in the timeline, we can see that the get product list, I don't know if you can see it, it's a bit small, but the get product list takes the longest. So if I click in the timeline on this specific span, the span details will open for me. And by analyzing and by looking at the span details, and also you can see in the graph view that I don't see any errors, right? I don't see like any red lines or something. But if I look at the spans attributes, I can see that the app's product count is extremely high, and also like the app cache hit is false. Makes it suspect a little bit. What I would do next is I'll go back to the search page and perform two different searches. First one will be cache hit equals true. Second one will be cache hit equals false. And when I do that, I can compare between these different searches and see the duration. So when the cache hit equals true, I can see that the duration is okay. But when the cache hit is false, it increases extremely. And this helps us understand that and confirm our diagnosis. And of course, now we need to solve the problem, but at least we found how this problem happened. Okay, so I would like to hopefully go over a quick demo. Hopefully everything will work. Sorry for that. Okay, so first thing I want to show you is the GitHub page for Teletrace, where inside Teletrace we have the OpenTelemetry demo. We have the entire repository when you can go over the source code for yourself. And we also have the guide and the explanation of how to run the demo and what are the different services that you can look at when using this demo. You can also go for the demo documentation of OpenTelemetry. And what I want to do is actually, like, I ran the Docker in advance to save some time, that it seems to everything works fine. And what I will do next is I'll open the OpenTelemetry demo, which, as I said, is a web store for telescoping equipment. And when I navigate a little bit, everything seems fine, aside for the bit latency here. Okay. So if I'll click like on a specific product, still looks fine. But when I click on this product, I have a bug, right? I can't see the image, I can't see the amount of money it costs. And now I want to try and understand why the error happened. So I will open Teletrace page, and again, you don't need to remember any of the URLs. Everything is shown on the guide. And this is the Teletrace search page. And now I don't really know what service is related to this issue, but what I do know is that I have the product ID in the URL. So I'll just copy it and perform a quick filter. So if I'll just filter by product ID, sorry. Okay, I just didn't copy it. Okay, and now I want to see only the errors. Oh, sorry, filter by OK. I want to see only the errors of this product. And now I'll just click on a specific span in order to go over the trace view page. And as I said, we have the different visualization. I can just drag this timeline to see all the spans. And I can see the error immediately from the product catalog service in here, in the service. And it really like pops up that we have an error, and it says product catalog service fail feature flag enabled. So that's it, right? And I'll go to the feature flag service, and obviously this is for demo purposes, so everything has a nice UI, but you can just think of it as like a variable that was misconfigured or some database entry that we need to change, right? And here I can see that under product catalog failure enabled true. So I'll just edit it. And this is also like if you try to use the demo, you have the different errors that you can use in order to see what happens when you do these different errors. I'll just disable it and save, and let's see what happens next. Ta-da! Everything works fine. And it was like, what, 2-3 minutes of using Teletrace in order to analyze and visualize everything. So what I would really like you to take from this talk is that when you put the effort in collecting the telemetry data correctly and using a tool such as Teletrace or whatever backend that you can use, it can save you a lot of time when you have issues. It can save you a lot of headache and frustration, and when we do have problems in your system. And sorry. And actually that's it. I did it a bit fast. It was my first time lecturing ever, so I talked a bit fast, but thank you. Are there any questions regarding OpenTelemetry, Teletrace, or any other topic that we talked about? Yeah. So only automatic instrumentation in my demo. Yeah. And yeah, another thing about automatic instrumentation or instrumentation in general, if you want to try to use OpenTelemetry, I would just go for the automatic instrumentation, and if you see that it doesn't provide what you need, then try to go over the manual instrumentation and see what else you need to add, maybe combine the two. But the automatic instrumentation is really good, and it really saves a lot of headache and a lot of time and money from the development team. Okay, any other question? Okay, so a last word. If you're interested in OpenTelemetry in general, I will extremely recommend you to go over to the OpenTelemetry documentation, where you can find a lot of explanation. For example, how can you implement the collector inside your application, talking a little bit about how to scale, how to use the collector, maybe have more than one collector in your application in case you need to scale it, or in case you have different issues that needs to be discussed. And yeah, that's it. If you have any more questions, I'll be here in the next half an hour, so feel free to reach out and talk to me. Thank you.